G'day Year 7 mathematicians and welcome to another lesson on angles. So last time we were estimating and working out angles with 180 degrees and measuring them. This time we're actually going to be drawing them. So make sure you've got a protractor at the very least. If you can, once again, print out the worksheet. If not, you can simply do it all on the screen and later on you'll have to just copy down some very simple straight lines to construct the angles in your book. Okay, so draw a line under the last lesson's work, the date, and then today's title, draw angles up to 180 degrees. Your do now task is to measure the angles as highlighted on those 5 questions. Make sure you're reading correctly off either the inside or the outside line of the protractor, depending on where the 0 sits on the baseline. Okay, and like I say, if you can't print it out, simply put your protractor onto your laptop screen and you can measure it from there. Okay, so pause the video and have a go at those 5 for me. Okay, and once again, we should be getting something similar to these numbers. May just have a difference of 1 or 2 degrees either side, depending on obviously exactly where you put the protractor. So I've gone with 129, 132, 50, 66, and 129 degrees. So today's hook, Paul Pogba wants to release a new comic book called Pogball about his football career. Now he's working with an illustrator and designing his new character. He tells the illustrator that to do the perfect dab celebration, your back arm should be pointing at 120 degrees. Okay, so on the picture, his arm there needs to be at 120 degrees. How would the illustrator be able to draw this accurately? What would they need to do? And explain this to the person, I will say next to you, so by all means go and find whoever you live with and you can try and explain that to them for this lesson. And then they've had a go at the drawing there. Does it look good there? Does that look accurate? Is that pointing at 120 degrees? Okay, so once again, have a look at it now, and that can be something that will be revisited towards the end of the lesson once we've picked up a few more skills along the way. So we're going to learn how to draw an angle at the end of a line segment, understand how to draw an angle at a specified point on a line, and then draw angles at both ends of the same line using different scales. So construct a 70-degree angle, and this is how we are going to do it. Okay, so you're going to draw a baseline segment to work from, and I would like you to do this into your exercise books as we do this, following each step along the way and writing these down for me. So step 1, baseline segment, a nice simple straight line. Place protractor at one end of the line segment. Okay, I've chosen the left-hand side, so for ease, I'd just like you to follow and do the same. Step 3, measure around to 70 degrees from the 0 measure on the line segment. So the baseline's on 0, the 0 is the inside number, so we're going to use the inside there, mark on 70, then mark a dot at the point, we've done that, remove the protractor and draw a line connecting the end of the baseline segment to it. So remove the protractor and then simply a straight line through that. It can go way beyond the dot, that doesn't matter. It's just got to go on that line there. Then we tend to do that notation, simply write 70 degrees. And that then is our 70-degree angle constructed. So I would like you now to construct a 50-degree angle and a 110-degree angle following exactly the same rules. So pause it there and then I'll put up the answers for those. Okay, so once again, baseline, put the protractor on, we've measured round from our baseline to 50, put the dot on, then draw our straight line there, label up, we've got 50 degrees. Next one, 110 degree angle there. So that should be what yours look like, okay? So if the angles so far, we've drawn them from the left-hand side of the line segment, what would happen if we did it on the right-hand side? Is there any difference there? So this time we've labelled our line segment AB. We're going to construct an angle of 35 at point B. So protractor goes on, 35 degrees the dot, draw our line straight through it, label it up, 35 degrees. Okay, so same technique there, just make sure on this point that the baseline, the 0 is on the outside number, so we can use the outside numbers for 35 degrees, put your dot on, remove it, straight line from the end then of our baseline. So I would like you to do an angle of 63 degrees at point D. I'll pause it there, have a go at that one for me. And again, if you haven't got a worksheet, simply draw that straight line CD. It's just a simple, straight, horizontal line there. Okay, so now you've had a go at that. Protractor goes on. Baseline, we've got the 0 as the outside number, so measure around from the outside 0 to 63, put a dot, straight line through it, 63 degrees. Okay, and I would like to see sort of that notation where you put a little bit of curve in there to highlight it even further and make it clear with your 63 degrees. Next up, point F, pause again, 138 degrees please. Okay, so protractor comes onto the baseline, 0 is once again the outside number, follow it all the way around on the outside number to 138, put a dot, draw a line on, little curve there, 138 degrees, and that's exactly how we are going to do this every time. So, next up, angle of 55 degrees at point C. So, this time we're going for the middle. We're not going for the end of it, we're going at point C. And there is a couple of different ways we can do this. For now, we'll just look at this first one. Put your protractor down onto C, so it lines up with the letter C. Obviously, this one will not be quite as exact, 'cause it's just a letter, depending on where you've gone for the middle of the letter. And we've gone the baseline. We've used the left-hand side here as at 0 degrees, and we've gone up to 55. Put the dot on, straight line, label it up. And this is why it's very important to put that curve on to say which side is the 55 degrees. Because some of you may have noticed we could have gone the other side of C and measured 55 degrees on the other side of C. We will look at that in one more moment on the next slide. Okay, so for you, I'd like you now to have a go at angle 60 degrees at point F. And point F is in the middle there. So again, if you've not got it, just draw that in your books for me on that sort of that angle for the line DFE. Okay, so I'll put my protractor on at 60 degrees, and I'm going to mark, there's my 60, there's a straight line. But we could also say, if we went from the other side, so at E, where we've got 0 on the inside numbers, we could measure 60 degrees, and that would also be 60. And then, if you have a look at that bottom question there, on the same line, draw an angle of 6 degrees the other way around. We've got 2 of those on there. This creates an angle in between them, and I'd like you then to have a go at measuring that angle, and what do you notice about that one, and why do you think it would be that? So the middle angle there, you should notice, is also 60 degrees. That's 3 60-degree angles created. Add them together and they make 180 degrees. And what do we say about angles on a straight line? They add up to 180 degrees, and that is why we've got 3 lots of 60 to make 180 degrees there. Okay, so these are the things I'd just like you to have a think about, and do please pause the video here to think about these carefully. How do you choose which scale to use on a protractor, so the inside or the outside? Is it possible to draw an angle of 180 degrees? And why are there 2 scales on a protractor? Okay, so a few more examples here. I'd like you to draw an angle of 58 at B, 115 at A, and then 70 degrees on the last one we're going to do at C. And for the last one, for a little bit of bonus work for some of you there, I'd like you to draw either side of C, the 70 degrees, and once again, measure the angle that's created between those then that you've drawn. Okay, so pause the video, have a go at those for me, please. So first one, B, we'll go at 58 degrees. Angle A, oh sorry, that one should have come up then saying in writing 115 degrees. On this last one, angle C, that's my first one. I've gone for the left hand side, and that would be 70 degrees. I could equally have gone on the right hand side there. Both are 70 degrees from those little curves there, and the angle between them, if you measure that, should be 40 degrees, because 70 and 70 is 140. The angle between them, another 40 degrees, is 180. They all then add up to be 180 degrees. Okay, non-standard then, because we've got the lines facing sort of different sides. We've got a vertical line, one already on an angle. Follow the instructions on there for me and pause the video to have a go at these non-standard examples for me. Okay, angle of 43 degrees at A. Those are the angles I've got for A, it's 43, B is 105. Now this last one, draw an angle of 50 degrees at C, that's my 50 degrees. Angle of 70 at D, and make sure it says draw the line so they cross. So all you have to do, you don't change the angle, you just draw a slightly longer line to make sure they cross. Mark this point E. What is the size of angle CED? Now, I expect you've all measured that with your protractor and it should be 60, but we could potentially have worked that out first to know it's right, because we know angle ECD would be 50. CDE, that we've already measured well, would be 70. All three angles in a triangle out to 180. 70 plus 50 is 120. Take it from 180, that would leave 60 degrees for the angle CED. There we go, 60 degrees. Okay, so Teddy is drawing an angle of 35 degrees. He marks the angle with his pencil as shown. Will Teddy's diagram show the correct angle? How do you know? Okay, so I want you to have a think there. What's potentially has gone wrong there for Teddy, or if you think so, what has he done correctly? So to me it looks like there he has not lined up the crosshairs exactly on the protractor. We'd be wanting to move those down a little bit, and we should have this crosshair should be down on the point there that we're measuring from on the line. Okay, so he will have made an error there, and by all means trial that in your book, the difference, but obviously that is going to create a different angle, not the 35 that he's trying to draw. So Eva, Mo and Whitney have drawn a 63-degree angle at point A and a 15-degree angle at point B. Okay, what I would like you to do is to copy that exactly, that line there, and the distance between your two marks in your book, A and B, should be 4 centimetres. I'd like you to follow the instructions of 63-degree angle at point A and 15-degree angle at point B, and then see if Eva, Whitney or Mo are correct. They're all correct, 2 correct, or perhaps even none are correct. Okay, so have a go at that and think carefully when we said earlier about drawing these angles, perhaps which side could they go? Okay, hopefully you've had a good crack at that. So Eva said her lines have made a triangle. I think that's absolutely right. They could well make a triangle. The 63-degree angle, if you drew that coming from the right-hand side out of A, and from point B, the 15-degree angle coming from the left-hand side, you will clearly make a triangle. So I would absolutely agree with Eva, she would make a triangle. Whitney has made, her lines have met again, but they've made a different triangle to Eva. So how could she have made a different triangle? Well, perhaps if the 63-degree angle at point A, you did the angle coming to the left-hand direction for 63 degrees, and then B, 15, also went to the left. If you draw those two lines long enough, they will again make a triangle, and it will be different to Eva's one. Mo says his lines don't form a shape at all. Well, let's have a think. If we've got angle 63 at point A, and we did that to the left, still being 63 degrees, but heading off in the left direction, and then on point B we did 15 degrees, but headed that in the right-hand direction, then they would never meet, and so he would not form a shape whatsoever. So if you did all those sketches and showed those points, then I in fact would agree with all 3 of those individuals. So I think Eva, Mo and Whitney could all be correct based upon those reasons. Okay, last bit of purposeful practice here. I would like you on each diagram to measure and draw an angle of 115 degrees at point A. And then this is just to see perhaps where people have gone and what are the differences we could do. Okay, so pause it there See how many different ways you could do 115 degrees at point A. Okay, so what I'm going to show here is we've got first line here, that is 115 degrees at point A. But what we could also have done is drawn it on the other side. And that mark there is still also 115 degrees. Okay, you could have drawn it either side of the line there, because it doesn't specify. You could have drawn on top of the line or perhaps underneath the line, and you could do the same for the other two, which I haven't marked on, but you could draw them above the line for that one on the angle for the next one, part 2, or equally you could draw it below the line as long as they still measure and you've marked up clearly which part of it is 115 degrees. So last but not least here is the true or false. Now I've only got 6 here for you today, and I'd like you to pause the video, read over and answer all 6 first, then we'll go through them and you can give your score out of 6 at the end. Okay, so let's see how we did. So when drawing an angle, I must ensure the crosshairs on my protractor are positioned over the point my angle is being drawn from. Absolutely. It's exactly what you need to do, and that, I believe, was the mistake that Teddy made earlier. He didn't get the crosshairs lined up with the point he wanted to, and so his angle would not have been correct. When drawing an angle, I can read off either scale on the protractor. No, you can't. No. You must read from where the baseline is at 0. Okay, so you would read up from there. I can draw an angle of 50 degrees from either side of the line segment. Yes, you could. So if we had the line ABC with B in the middle of the line, you could draw it going from the left-hand side of B or from the right-hand side of B for 50 degrees there. When drawing an angle, I must measure from 0 on the line segment. Yes, you must. And if asked to draw an angle of 40 degrees at point B, I could do it above or below the line. Yes, you could. That's what we looked at on the previous slide there. It doesn't specify which side, and again, as long as you mark clearly what you have measured and write 40 next to it, that is absolutely fine. When I look at a protractor scale, both numbers add together to give 360 degrees. Well, there's a little protractor on there, and hopefully we can see that is false. They will always add up to be 180 degrees, 180. So if you look to the inside and the outside numbers, you'd have 170 plus 10, 180, 160 plus 20, 180. All the way around, those two numbers will add up to be 180 degrees. Last two there are false, so very well done for anyone who got those last two. Here's a few more. These are the bonus questions that I really want you to have a think about and push yourselves in the higher sets here. So pause the videos where you need to have a look over whether you believe these things are correct. Here's a little bit more information about where we could perhaps use certain angles and perhaps even some jobs in the future for some of you guys as you smash through mathematics at Delisle College all the way to 6th form. And then that's to cover the success criteria that we have looked at today. Okay, so well done again for another lesson. There are going to be 3 this week, I believe, so make sure you look out for the 3rd video and you've got your protractor and everything else ready, and double check the Heggerty clips, as that will be the work you need to submit to your classroom teacher. It's your Heggerty online tests. Okay, so thanks so much and speak to you again soon. Take care of yourselves then, Year 7.